in this tutorial, we are going to start getting our character moving with the WSAD keys. We are also going to add the shift key to make them sprint, because that's something most games nowadays have. And we're also just going to cover jumping in this video, because jumping is going to be fairly simple with the Unreal character blueprint that we are using. To begin, I've made a few changes to the level, not that many. All I've done is add some cubes, as you can see here, of various sizes, and what this is going to help us with is just visualize our movement relative to these objects. It just makes it a little easier to see. So to start, let's just come into our character and let us add the controls we need. So we need W, S, A, D. We're going to use the left shift button to sprint, and we're going to use spacebar to jump. So let me start by adding the W. I can search for keyboard events and then W. And you can see we don't want debug, but under keyboard events there is a W. We could go ahead and type in keyboard events and hit S, and then add S that way, but there's a much easier way to do this. We just copy paste it, and in the right side under details there's a drop down box here, and there we can search for the next one, which I want is D. I don't want it, it's not a gamepad event, it's a keyboard event. There's D. So that's a simple way of changing it. Even simpler than that, next to this there's a little keyboard icon. Click that. You can see it's turned yellow. That means now the game is listening for my input. I'm going to click A, and you can see that it changed it to A. That is probably the simplest way to do keyboard events. I believe it also recognizes controller events, so when you plug in your Xbox controller or whatever and you hit a button, it should do the same thing. Let's copy paste this, and the next one is left shift. This we're going to use for sprinting, and finally we're going to use spacebar for jumping. So before we get into the actual code, let's just see what this character event does, or this input event. And to do that, just like with anything, we're going to print string. So it has two functions, pressed and released. So I'm going to just do one that is W is pressed, and one more that says W is released. So on released, I'm going to plug it up to 1, and on pressed, I'm going to plug it up to the top one. If you think back to our mouse event that happened on tick, let's see if this also happens on tick. And we can see nothing is printing. When I hold W down, it prints W is pressed. I'm still holding W, but it's not continuing to print. When I let go of W, it prints W is released. It's not continuing to print it, even though I'm not pressing the W key. So what this means really is that this event of keyboard presses, it happens only once, and it happens the second we press it. So when I press W, it presses. When I release it, it releases. This is good to know. It's going to help us. It's going to help inform how we use these events to create our character's movement. I'll delete these for now. So let's talk about how this movement actually works in the character. And we can do that by looking at our viewport controller. Let me just make the screen a bit bigger. So now I'm going to hold forward, or W in this case, and my camera is moving forward. When I turn my camera, it still continues to move forward, but what forward means is changing. I'm moving towards this cube when I'm holding W, but if I face this cube, I'm going to be moving towards that. Same thing if I turn around all the way here. So what forward is relative to where the camera is facing. And that goes the same with backwards. Now I'm moving away from this cube. If I turn, I'm moving away from this cube now. And same if I turn 180, I am now moving away from the cube furthest to me. This is also true for left and right. When I move right and I turn the camera, it is moving relative to my camera's right. If I move left and move the camera, it is moving relative to my camera's left. So let's take a look at what that looks like. When we look at our player start, you can see there's this little blue direction. It doesn't matter if I'm rotate, scale, or translate. We always see this blue little line, and that represents our forward. So currently I am on the world coordinate system, and you can see when I rotate the object, that blue line is changing where it's pointing. But if I go back to movement, my x-axis has stayed the same. I can move it more, and you can see the x-axis is still there. But if I was to cycle it, you can see the x-axis is now pointing towards this blue line, our forward line. When I rotate it, the x-axis stays to it. When I turn it back to world coordinates, we can see that the x-axis doesn't change, or it changes back to default. You can also see the y-axis is changing. It's always going to be right relative to this vector. So on local coordinates, if this is pointing forward, the y-axis is always pointing to the right of it. Again, forward. This is pointing to the right of it. And so that is what we mean by relative rotations. All objects hold an inherent forward direction. It holds an inherent right direction. And we call the z-axis an up direction. So when our player moves, when they hold W or S, we want them to move relatively forward. Not Unreal's world coordinate system forward, but the actor's relative forward. And the same thing, when we hold the right key, we want it to move the actor's relative right. So W and S are both moving forward. W is just moving positively forward. S is moving negatively forward. And the same thing with A and D. D is moving positively to the right direction, and A is going to move negatively towards the right direction. I'm just going to reset this. And let's go take a look at this forward vector and right vector real quick. So on my event tick, I'm going to grab the camera. And we're using the camera because when we rotate our character, we know the camera rotates. So let's just use it because the camera always points to the correct forward. And I'm just going to type get forward vector. You can see it prints out a vector. And let's just print it. Just to make things a little more visually coherent, I'm going to go into key and I'm just going to type in forward. So now it's just going to print one value, and that's just going to change as the forward vector changes rather than constantly printing things out, which makes it a little hard to read. Hit play, and you can see, just like we mentioned, forward is the local x-axis. So right now our character's forward is 1 on the x-axis. It's pointing in that direction because it's 0 on both the other axes. When I start rotating my mouse, we can see that what forward means is changing. As I change my cameras forward, you can see that forward is changing. And that also means the relative direction that we need to move changes. We could also delete the forward and see the right vector. So get right vector, plug it in. We mentioned that the right vector is 1 on the y-axis, which is where it starts when we're looking default. And as we rotate it, we can see that it changes. What values it changes to specifically doesn't quite matter. What matters is that it's changing. And now we can use this to help build our character. I'm just going to delete this print string now. And because we're using the character movement component, there is a function already there for us that will take our inputs and turn it into movements, which is very useful. I'm going to right click and type add movement input. And you can see there's a function called add movement input. The target is the pawn, which is this character itself. And it has a target, which is ourselves. And it has a world direction. This is the direction that we want to move in. And this is what we're going to be setting. So let's just start with forward and backwards movement. I'm just going to get forward vector. Now, if I was just plug this in here and compile it and run it, my character is just going to be always moving forward because it's going to be moving relatively forward. And you can see as I rotate my mouse, what forward means changes because we are using the forward vector of our camera to tell Unreal which direction to push our character in. But we want it to actually be controlled by W and S. We don't just want our player running forward constantly. So instead of just directly plugging it up, I'm going to multiply this value with a float. and I'm just going to make a float and call it forward input. Get that float, plug it up here, and then plug that into my world direction. So what do I want this forward input to be? I want it to represent our W and S presses. So when we press W, I am going to set the forward input to 1. When we let go of W, we're going to set the forward input back to 0. And same thing with the S key. But remember, S is just moving forward on the negative direction. So we are just going to do that as -1. Compile it, come back here. You can see that works perfectly. Now we can move forward, we can move backwards. So next, let's do the A and D directions. And to do that, I'm just going to get the right vector. Get right vector. And we're going to do the exact same kind of concept. I'm just going to make a variable, call it right input. We are going to multiply, change the target type to float. And let's just multiply it by this right input. Now all we need to do is take these two vectors and add them to each other and plug that into our world direction. So just like we did with our W and S, let's pull out a set input and let's copy paste that a few times. So when we press A, we want to move left. So that is a negative right vector. When we let go of A, it's going to be 0. When we press D, we want to move positive on the right vector. When we release D, we want to stop moving. When we can compile it and run it. And once my Unreal stops lagging, we can see when I press W and S, it moves us forward. When I press A and D, it moves us relatively left or right. And we can combine A, W, S, A, D as well to move comfortably in all directions. And so that is really our movement complete. Real quick, I just wanted to illustrate if you guys are having a little confusion on why this math works. Let's just think about the forward vector. So let's just have, what we're really doing is forward vector multiplied by the input. The input can be a 0 or a 1, and the forward vector can actually really be anything. So if we were to take the default forward vector, which is x is 1 and then y and z are 0, and we multiply it, if our input was a 0, everything just comes out as a 0. So just in case you didn't know, the way we do a vector multiplication with a float is we literally just multiplied the value with every single value of the vector, and that's our result. So 0 multiplied by 1 is 0, 0 multiplied by 0 is 0, and 0 multiplied by 0 again is 0. If our input was 1, then 0 multiplied by 1 is 1, 0 multiplied by 1 is 0, and 0 multiplied by 1 is again 0. So when our input is on, we have our forward vector. When our input is off, we don't have any vector. It's all 0. And this doesn't matter if our input 0.1 or even if it's 0.5, 0.5, 0.5. Same thing applies. If our input is 0, everything is 0. And if our input is 1, everything is turned on. So we get the direction 0.5, 0.5, 0.5. Same thing works for the right axes. And all we're doing at the end is just adding this input along with the right input, and vector addition works the same way. We just add the x components, the y components, and the z components, and that gives us our output. We plug this into the direction the player wants to move, and Unreal moves our player in that direction. Now, one thing to note here is this player movement, this movement input, doesn't determine the speed of the character in any way. So if I change this forward input to even something very large and come back and play, that doesn't actually affect how fast my player moves. My Unreal is lagging slightly, but you will see when you try it, that doesn't change what your character's move speed is. I'm just going to change this back to 1. If we did want to change our move speed, and let's say we do, because that's what I want left shift to do. I wanted to change our character's move speed. I wanted to make our character sprint. We can see under our character movement, we have max walk speed under character movement walking. Currently it defaults to 600 centimeters a second. Let's remember that value. When I press left shift, well, first let me just take this character movement out. When I press left shift, I want to set the max walk speed. And its defaults at 600. Let's change it to 1000 for our sprinting. When we release it, we want to set it back to the default, which was 600. So let's just plug that up, and there you go, sprinting. When I run forward and I hold shift, my character moves faster. When I let go of shift, they move slower. Very nice, very simple. Again, super cool that Unreal just gives us these functionalities with so many options for our character class. Again, something you guys should try and play with. And finally, let's just end this video off on jumping. So another nice thing and reason we're using the Unreal character class is because it comes with gravity and ground detection. Really, it comes with a jump function that we're going to just use. But you can see if I drag this player start up, so my player is now starting in the sky, I hit play, my player falls down. Very nice to know and great that it's there. So let's use that. When we press spacebar, and this is probably the simplest part of this, all we're going to do is type in jump, and you can see there is a jump function and the target is this character component. We can hit spacebar, hit play. When we fall, I can hit space to jump. If we wanted to change anything about our jump in our movement controller, we have some settings here. You can see jumping and falling. We could change our jump velocity if we want our character to jump higher. There's air control, so how much control does your player have in the air? If this was set to 1, we will move exactly like we move in the ground in the air. This is set to 0.05, so we're going to move very little. We're going to have very little control when we're in the air. So again, play with these values. You know, if you're making a platformer, you might want the player to have more control in the air, less committed jumps. I'm sure, again, when you guys play games now, think about the air control your player has when they jump. It's something developers tweak a lot to make the characters really feel alive and feel their own. Yeah. And finally, the other thing you guys might want to do is have a double jump, triple jump, quadruple jump, whatever. Let's just click on BP first person character, and I'm just going to search max jumps. And you can see under character, I have max jump count. Mine is already set to 2. It should be by default set to 1. If I change it to something like 5, now we have 5 jumps before we touch the ground. Go back here. And you can see I jumped 5 times, then I was spamming the spacebar button and it wasn't letting me jump anymore. Again, super cool, super simple. We can have the character jump as many times as we want. And the other cool thing about this, again, is that we can set up our jump count as it's a variable, so we can change it. So we could always do set max jump count, and you can see I can change this. So again, maybe when we work on collectibles, you want to have it so that when your player picks up 10 coins, they get an extra jump added. We might be able to indicate that in the UI. Very simple. Unreal's character is super powerful, has a lot of features to it. I have added a resource link again to the Unreal documentation that explains a lot of this stuff. And when you make your level, feel free to tweak your character, feel free to change these variables, and really, again, make the character feel alive, feel like your own character, suit your level design. If you want multiple jumps, add multiple jumps. If you don't want sprinting, don't have sprinting. If you want your character to move quickly, change their move speed. We can even change their friction on different surfaces. There is a lot to play with here. But with this, that concludes us making a character. We have a fully functional character now that we can play with. It can jump around. We can solve puzzles because of that. We will cover the last portion that's going to help us really make a game next, which is collisions and collectibles. That will help us, add interactivity to our game, whether it be picking up collectibles or maybe a pit that we fall down that kills us. Collisions really are the basics of all that, and we will look at that next. But for now, big claps for yourselves. We have made our very own first-person character controller all by ourselves. Thank you for watching.